I'm Andisiwe Mvunelo, an honors student at Walter Sisulu University under the supervision of those two people. My project is a puzzle piece of an ongoing project conducted by my co-supervisor, Dr. Paula Patrick from SciHub. What I am doing is I'm using DNA barcoding to identify fish larvae. Coastal fish species generally have a pelagic larvae that lasts from hours to months before they actually settle in their juvenile or adult habitat. Fish larvae differ morphologically in comparison to their adult counterparts, which makes the species identification of most coastal marine larvae to remain elusive. The correct identification of the coastal fish larvae will allow estimates of biodiversity for regional checklist, pelagic larvae duration, the species occurrence and distribution. Also, monitoring settlements and habitat requirements for specific species. What is this DNA barcoding I am talking about? DNA barcoding is a taxonomic method that uses a short genetic marker of a gene, of an organism's gene, to identify it belonging to a particular species. Ecological studies of diversity and distribution of plankton larvae are said to have grown to have become more dependent on molecular methods in finding accurate taxonomic identification of species. Identification of larvae has to be the first foundation step of biodiversity data in order to have meaningful systematics or ecological research. Studying biodiversity at species level requires accuracy for assessment of communities. DNA barcoding comes as a useful technique with its ability to identify or to analyze species from the tissue level up to an adult organism. DNA barcoding is used for species identification as it provides taxonomic basis for ecological inferences. There are numerous studies that have been done using this method which indicated that the correct identification of fish eggs larvae allows us to estimate or to actually follow what species is spawning where and when, the nursery grounds, when is it hatching, and possibly their migratory routes, which could become as portable information for conservation purposes. It also enables retail substitution of species to be detected, which assess managing fisheries for long-term sustainability and improves ecosystem research and conservation. The aim of my research is to contribute to a DNA barcode reference library for larval fish occurring in the shallow coastal waters of the east coast of South Africa. This is my study site where my samples were collected. That Black Dot Bay, Algoa Bay, which is close to Port Elizabeth. The data forming the basis of my project was collected in the year 2015 within the shallow coastal waters between Cape St. Francis in the west to Algoa Bay in the east. Further data will be collected as this is an ongoing project. After my data was collected, sorting and identification of larvae to the lowest possible level, taxonomic level, was undertaken in a SciHub laboratory. The sorting involved separation of fish larvae from the other plankton and also preserving my tissues in good condition. Prior the molecular method, which is DNA barcoding, there's certain information I needed for each sample, which involved detailed geographic information, high-quality photographs taken using a stereo microscope, which were then followed by DNA extraction, polymerase chain reaction, which is PCR, and cycling sequencing as the second last step. Then the sequencing results were then loaded on board to identify the species. This sorting of fish larvae is pretty much what I've already talked about. To extract my DNA, I used sorting method, and then I ran the concentration of DNA using a nanodrop, which is an app that's loaded on the computer, and after which I got the concentration, I I performed a PCR method, which was ran on the agarose gel electrophoresis to confirm if the PCR has actually worked. If the PCR has worked, the product is further purified and vortexed and prepared for cyclosequencing. Sorry. This might sound fancy and all nice, but it's not as easy when you are doing it. As a result, out of the 39 collected larval species, only 2 successfully worked. The 30 of them failed in the PCR, and 5 of them worked all the way until the cyclosequencing. We suspect that the failure is due to maybe it's the wrong preservation, or it's the primers used when performing the PCR, or it could be that I lost the DNA samples when I was doing the extraction. That's still to be verified. The 2 that successfully worked are there's lovely babies here, Pocostoma dentata and Idorosomus inodorus. Pocostoma dentata is popularly known as Dane. It's this beautiful, lovely fish with colors. It's distributed from Port St. John's to Kai River as you go towards East London, and it strays along as way as Algoa Bay. The identification of this fish in this site that does suggest that Algoa Bay might be a possible spawning area for this fish. My second baby, Idorosomus inodorus, which is also a lovely fish known as silver cop. It is irregularly distributed in the southern Africa, and it goes as far as the northern Namibia. This fish is important to identify its spawning sites because it is known to have been exploited for over 150 years. So actually knowing where it spawns, its migratory routes might contribute to it being conserved. Sorry. DNA barcoding is an essential addressing level in addressing larval identification challenges with its ability to correct field misidentification, reduce ambiguity of species identification, make species identification to be more exact, create an open access database of marine larvae. The integration of morphological and physiological data together with the DNA barcoding will improve species discovery and identification. Identification of harvested species by the study indicates a need for further data collection at Algoa Bay. I recommend that further studies should be done on the east coast of South Africa, specifically the Algoa Bay, as more data is needed before making any general conclusions. Further DNA barcoding studies throughout the SA coastal line, as this could inform conservation of larval hotspots. These are, I acknowledge those people, the NRF, SA Police, my supervisors, field assistants, especially the Ocean Steward program, for making it possible for me to be here. Thank you.